want you to write the equation of the line for that function. Write the equation of the line for that function. You know what a line is, right? Okay. What does a line have? It has a slope, so let's start there. Let's find the slope. How about that? Okay, find the slope. Mark that go. All right, once you have the slope, what is the slope, by the way? What? 4? How do you know? Right? 8 minus 4 over 3 minus 2 is 4 over 1, which is 4. Okay, so M is 4. And then what happened? Plug in a point. Okay, do you have a favorite? This one? Okay. Alright, so you can do two things here, okay? You can go with point slope form, which is y minus y equals n times x minus x. Or you can go straight into slope intercept form and try to solve for b. And you do this one and then just move that over. I don't really care. Which way do you want to go? That one? Okay. I'm going to do both. I don't care. We'll do this one first. Okay, so tell me what to write. No one knows what to write? 4? Yes, that's a good place to start. And now I'm putting an equal sign. And then what? 1?
Or 4.
4 equals 4. That is a true statement. Yes. Times 2. Okay. All right. Plus what? Plus 8. Okay. So 4 equals 8 plus b. Does everyone see where all of this came from? Okay. That means negative 4 equals b. So the equation of the line would be y equals 4x minus 4. Alright, I'm going to go with point slope form over here. Just to show you. So we get y minus y equals m times x minus x. Y minus 4 equals 4x minus 8. Y equals 4x minus 4. Do the same thing either way. Just depends on where you want to start, because you should end up at the same place where you want your starting point. Now graph that line. Why are you growling? Was it someone in this class asked me like 900 times to use a graph paper, or was that a different class? Someone kept asking me about the graph paper. I don't remember who it was. So, where do I start? Okay, what's my y-intercept? Here? And then what happens? And over 1? And then what? I don't want to do it again. Why do you have to? Okay, I generally use straight edge, so I'm good. You don't use a straight edge to correct your line? Actually, it wouldn't be any more precise up here. I'm really looking forward to that board because I think it's going to be easier to correct the line on that. Right? Alright, what do you remember about parallel lines? They stay the same distance apart, they have the same slope, they never touch. Right. The slopes are equal. How about perpendicular lines? Yes, what? Yes, they're opposite reciprocals or negative reciprocals. Slopes are opposite. Okay, great. Yes, very good. Um, so let's see. Find the equation of a line. F of x equals 6 plus 3x. Find the equation of a line that is parallel to this, parallel to that, but it passes through 3, 0. Alright, if they're parallel, what's the new slope going to be? 3, right? So set this up. What do I need to write? What y equals 3x minus 9. I totally would have gone with point slope on that one because you have y equals right there. Y equals 3 times x minus 3. Y equals 3x minus 9. Look how many fewer steps that was. Alright, last thing we're going to talk about, well, not last thing, but next thing we're going to talk about, intersecting lines. Got it? Where do these intersect? You know? Where do they intersect? How do you find out? What? You could graph. Have you seen my graph? Did you see this one? Yeah, I wouldn't do that. Graphing is only as reliable as your actual graph is. This one's y equals, and that one's y equals, right? So why don't, if y equals that and y equals that, then wouldn't that mean that those two equal each other? Yeah? And if t is 9/4, can I find out what j of t or h of t is? How? How about 5 minus 9/4? That one seems pretty easy. So 5 minus 9/4, which can be what? 20 minus 11/4. So these intersect at 9/4. Remember, at all, remember ever hearing the word substitution and elimination? Yeah, that's what that was. And with those being fractions, I mean, that's 1 3/4 and that's 2 3/4. That would be horrible to actually graph by hand. You have to use your calculator. And then, again, you would only be as right as, well, I don't know, y'all know how to put that in your calculator? Alright, I'm going to give you an easy one to do by yourself. Find the point where fx equals 2x plus 5 intersects with g of x minus 5. So 2x plus 5 equals negative 3x minus 5. And I end up with 5x equals negative 10, and x is negative 2. So let's see, that's negative 4 plus 5 is 1. So this intersects at the point negative 2, 1. Is that what you got? Yes, right. Yep. All right, so look at example 1 here. Emily saved up $3,500 for a summer visit to Seattle, and she thinks she's going to spend $400 each week on food, on rent, and fun. Okay? Find and interpret the horizontal intercept and determine a reasonable domain and range. Okay, so let's talk about this. Two things are going on here, right? She's got money, right? And she's spending $400 each week. So time and money. Those two things go together all the time, right? So she's got time and money. How much money does she have to spend? 3,500. So if we're talking about domain and range, what's going to happen with our domain and range on this problem? Which one's the domain? Which one's the range? Is time the domain? Is money the domain? What's the domain? What's the range? Time is the domain. Yeah, time is the input. Money is the output, right? So the time spent is going to determine how much money is spent, right? The time spent out. Where's she going again? Seattle. Okay. So all right. So if she has $3,500, and you said the money is the output, right? So what is our range here? Like if I ask you to write that out, then what's the range going to be? What's the most you can spend? 3,500, right? So to 0. Okay. So what kind of slope is this line going to have? Negative, because she's taking out $400 each week, right? So if I want to write this as a function, did they give me variables to use? Yeah, M and T. So M of T. What is this equation going to look like? That's it? Plus 35, okay. Plus 3,500. All right, that works for me. What else did they ask? Find and interpret the horizontal intercept. What does that mean, the horizontal intercept? The x-intercept, right? So what is the x-intercept here? Now this is my y-intercept. So if that's my y-intercept, that's how much money I start with before I even go to Seattle. What?
I heard something real loud.
Okay. What's my x-intercept? Solve that. That's your x-intercept, or your horizontal intercept. It's not an x, it's t. So it's the same thing. Question? Alright, so what's your horizontal intercept? So what does 8.75 mean for this problem? That's how much time she gets to stay in Seattle until what happens? Yeah, until she's broke. Right. She broke. No more money for her. Okay? Alright, let's look at Jamal here. This next problem. Maybe. Alright, Jamal's choosing between two moving companies. U-Haul charging upfront fee of $20.59 a mile. Budget charges $16.63 a mile. When will U-Haul be the better choice for Jamal? Okay. So the first thing you have to do is figure out what the two formulas are, right? So what's U-Haul going to cost? That's what I need to write? No. Alright. 0.59? Okay. With an M, okay. How about budget? Okay. So now I want to know, when does one of them become better than the other? So what can you do to figure out when one is better, less than the other? Find where they intersect. Yes, and they're already set equal. We're not actually going to find where they intersect. Alright, see this? This is homework that's in your book. I don't know if you knew that, but there's homework problems in your book. Let's look at number 1. In 2004, school population was 1,001. By 2008, population grown to 1,697. Assume the population is changing linearly. How much did the population grow between the years '04 and '08? How much did the population grow? That's a really easy subtraction problem. Okay, 696. How long did it take the population to grow from 1001 to 1697? 4 years. So what's the average population growth per year? Okay, which is what? What is it? 174. All right. So what was the population in the year 2000? What? They tricked me because 2000 is not up there. What am I going to have to do? Okay, so do that. Did you get it? What'd you get? 305? 305? 305. Alright, awesome. Find an equation for the population P of the school years T after 2000. So you know year 2000. So now what does year 2000 now become in this equation? No. What? I heard it. The y-intercept. Year 2000 is your beginning, it's your starting point, it's your y-intercept. You know your slope, because we've already figured out the rate of change. What's the rate of change? 174. Okay. So what would your equation be? Plus what? No, we didn't have 2,000 kids at that school. 305? Is that what you said? I cannot hear, apparently. So I'm going to know how many kids are going to be in the school in the year 2000 using this, or 2011 using this equation. Do I put 2011 in for T? What do you put in? Why 11 and not 2000? Right. T is years since 2000. Okay, great. So, see, these are in your book online. Problem